So the first one, we're just going to review some of the rules and do some problems and go through the steps of what the steps are to solve the logarithmic problems, and then we'll look at them in word problem form, okay? So, remember how to change this, like the big circle, how to change a log to an exponent, because we're going to use that, or vice versa. And your calculators, you need it. So, the couple in the bottom part that I think y'all got it, but we'll just go over them one more time. For any base, log base b of b to the x, if the base and the argument match, the answer is always the what? Yes. The exponent. Just kidding. That's right. All right, the answer is always the exponent. Okay. So with numbers in there, log base 3 of 3 to the 4th power, the answer would be 4, the exponent. Okay. So that means log of 10 to the 3rd power, if I don't have a log, if I don't have the base there and it's just a plain old log, right? That's the common log. So it's a base of 10. So the answer would be what? My base and my argument match. So the answer is 3. And the other way you might see it is ln of e to the 5th power. Ln e is log base e. So the base and the argument match. So the answer is 5. All right. Right. Still, for any base, if I have a base to an exponent of a log of that base, the answer is going to be the argument of the log. Here, the log base b and the base of b cancel out. That's 1. So the answer is x. Okay, so if I have 3 to the log base 3 of 6, the answer is 6. If I have e to the ln of 7, the answer is 7, because this is just log base e. Okay, good? Yeah. We are down in this big open space is where I wrote all these. Okay. And then the last one that I want you to remember is that drop down. So when the base and the argument are different, that's when we're looking for this one. So log base b of x to the n, we can change that because this is an exponent to an exponent, so it becomes a power to a power rule, which is just changing that to multiplication n times log base b of x. So these are the most common rules that we use when we solve logarithms problems. Right. Yeah, on the line with it. Yes. Yeah. Patrick, are you okay? You good?
Yeah, see the final, I think you're in the. You want like
There's extra packets up here if you need to just grab one for the day. Can't find it. All right. Okay. Can I erase everything that's on the board? Yes. Yes. Okay. So in the next it says we outline a general method for solving exponential equations when the variable appears in the exponent, because that's what we use logarithms to solve. So I'm going to give you 4 steps of what you should do when you're doing this. The first step is going to be to isolate the exponential part of the equation. So you're trying to get b to the x or b to the some number x, trying to get that by itself on one side of the equal sign. After that, and I showed you 3 ways to do these problems. You could take the log or the natural log, or the log that matches that base on both sides of the equations. Okay, and then we're going to use any of those properties of logarithms. So changing multiplication to addition, using the power to power rule, changing it to division, whatever we need, whichever one we need to use. We're going to use any of those properties of logarithms to solve it. What we want to solve is to solve the variable to come out of the exponent. And then the fourth thing is to solve for the variable. Everybody have a calculator today? Grab one, grab one. Practice on the calculator that you're going to use on the test. Don't practice with your phone. All right, we ready? We have an example there. 4 is equal to 3 times 6 to the x. So we have a variable in the exponent. That means that we're going to have to use logarithms somewhere in this. The first thing that we need to do is to get the exponential piece by itself. So we want just the 6 to the x. So we need to get rid of that 3, which is doing what with the 6x, 6 to the x? It's multiplication. So to get rid of the 3, we need to do what to both sides of the equation? Divide by 3. Okay. So here's where we may part ways in the way that we solve it. Some of you might take the natural log of both sides. Some of you might take the log of both sides, base 10. Some of you might take a log base 6. Since we have that change of base on our calculator, I would do the log base 6. It's one less step, right? So if I do this, I'm matching this base. So log base 6 of 4/3 is equal to log base 6 of 6 to the x. So the reason I picked the log base 6 of 6 is because that's 1. So that now I can use my property of logarithms that allows me to drop that x down in front and change it to multiplication. So log base 6 of 4/3 is equal to x times 1, which is just x. And now I've solved it. If on your homework it says give the exact answer, that's the exact answer. If it says round to a decimal place, you put that into your calculator and get the answer, which would be what? Negative. You got a negative? Oh, I forgot that. 0.16155. 0.05. All right. Okay. Yeah. No one here? Yeah, no. Okay. I have 0.161 in my papers, that's why. Okay, so, you're in your dorm and you don't have your calculator, doesn't change the base, and you're doing your homework, how do you do it? I would take the log of both sides, or the natural log. So log of 4/3 is equal to log of 6 to the x. So log of 4/3 or ln is equal to x times log of 6 here. We would divide by log of 6. And you get x is equal to log base 10 of 4/3 divided by log base 10 of 6. That's just your change of base rule, right? That we learned the other day. So if you're changing the base to a log base 10, it's log of the argument divided by log of the base. Okay, so we should get the same answer, 0.1605. I think you could probably Google a calculator on the computer that would let you put in a base of 6, but just if you ever get stuck and you're like, I only have my phone to do my homework, then that's another way that you could do it. Or you could use the ln, same thing would happen. All right. Try the next one on your own. Yeah, isolate this exponential, guys. You gotta get rid of the number in front. Okay, so yeah, 80 divided by 5 first. What was our time in? What were the units? Six. Not even a whole second. 0.350. Good with that? Anybody have a question? Need me to look at it? That's what you're erasing.
We get the right. 1.172.
Oh, you know why? Remember on these calculators, the thing that it doesn't like is to do answer divided by negative 0.491 for whatever reason. I have no idea why. When you use that, when that pops up, rewrite the whole thing because it's dividing it. I think it divides it twice or something when it does that. So make sure you use that fraction button and put it in that way. Okay, anybody else have a question with that? All right, so let's look at the next one. Did that give it to you right there? I don't know what the calculator does. Every other calculator that I've ever used, I love that answer button or when it just hit divide. But these does something weird. All right, a company finds that its daily sales begin to fall after the end of an advertising campaign, and the decline is such that the number of sales is equal to S equals 2,000 times 2 to the negative 0.1 x. Okay, where x is the number of days after the campaign ends. How many sales will be made 10 days after the campaign? So what does the 10 represent? It's a number of days. It's the x, right? Or the x, because it says x is the number of days. So for this one, S is equal to 2,000 times 2 to the negative 0.1 times 10. The reason I like to throw one of these in here is because y'all get so good at using the logarithms. It's like, oh, I got to take the log of both sides. We don't have to take the log of both sides. The variable is no longer an exponent. We just throw that into the calculator. It's all written right there with numbers. So we don't have to do anything besides put that in the calculator. Like that. Yeah. But y'all get so used to using logs to start going, oh, log of both sides. No, there's nothing to do with the log of both sides. What were the sales after 10 days? Okay, 1,000. All right, now, part B. The company does not want sales to drop below 350 per day. So what's the 350? Is that S? That's S. So now we're going to solve for X. So
Wait, S, right?
X. Yeah, 350 is equal to 2,000 times 2 to the negative 0.1 x. Okay, what do we have to do first, Bailey?
Divide
Divide by
by 2,000.
the 2,000. How long did y'all take? Log base 2. Okay, you could do log base 2. You could do log. You could do natural log. By negative 0.1 on both sides. Label my answer. What's the units? Days. We get 25.146.
So we would like round down.
To say, now go ahead and give me the decimals, because then I know you like haven't just guessed it, because on some of these, I had students last semester. They couldn't remember how to when to use a log, and so they just like pick values and start studying them in for X. So if you round, I don't know that you haven't done that much. Turn off. Because it says no guessing on instructions. Okay. All right. Any questions so far? We good? All right. The population of Greenwood was 30,000 in 1990. and 40,500 and 2,000. If the formula P equals P sub O E to the HT applies to the growth of a city for the population, what population is predicted for the year 2020? Okay, this one is a hard one. Okay, so let's look at this. They give us a year and a number, and then they give us another year and a number. Okay, so we have population time. So if we have time population, the input is my T, the output is my population, right? Because T is the variable in the equation and it's equal to P, it's like Y equals something 3x, right? So the T is the input, the output is population. Basically, what they've done is given me 2 points. They've given me a time, 1990, and they've given me a population of 30,000. Then they gave me another time. They gave me 2,000, and they gave me a population of 40,500. Okay, so I pick the earliest one, and I let that be my initial values. So my time, since that's my initial value, my initial year is 1990. So this is like years since T is in terms of years since 1990. Okay, so just kind of think about that. I don't know what the population was in year 0. So I picked the earliest one to be my initial year. So that means all of the time is based on that. So if I get time a time T equals 8, what year does that represent? 1998. Okay, it's years since 1990. All right. So that means that 30,000 is going to be my initial population. Okay. So I have P is equal to P sub O E to the HT. That's the equation they gave me. From that 1990, T would be 0 there, so that's not very helpful. But what is the 30,000? Where does the 30,000 go? P sub O, right? P naught. So right here, that's where my initial population goes. So that's going to be the 30,000. E. Does it even tell me anything about H? No, I don't know what that H even is. It's some kind of multiplier factor, but I don't know what it is. All right, so I'm going to now use the other point to plug it in. What is the population of the other point that I know? Huh? The 40,500, right? That's another population that I have. What else do I know from this point? 2,000, and 2,000 is what? What variable? T, it's time, but it's time since 1990. So what would T be? 10. Okay. E, we still don't know what that H is. H, but I do know that it is 10 years later. H is a constant in the equation. T is my variable. okay? So I have to solve and figure out what this H is before I can do anything else with predictions with that 2020. Because I want to know, the question says 2020, what is the population? But I have to figure out what this H is before I can do anything else, because I have too many variables in this problem. Okay, so let's solve this equation for the H. What do we do first? Divide by the 30,000. Good. Okay. We have a base of E, so what kind of log should we take on both sides? The natural log, or log base E. Erroneous 1, so I can bring that 10H down. Want to get the H by itself, so we divide by 10. H to be like 0.026. Point 0.03, okay. I have both those answers written on my paper, and I just assumed I'd rounded the 0.026 to 0.03. Okay, all right. Now we have the equation. So P is equal to our initial value, 30,000, E to the 0.03 T. Okay, so we did all that just to find H. Now we can answer the question. In 2020, what is T going to be? 30, because it is 30 years after 1990. Okay, so P, this is the one that Chloe liked because I don't have to use the log stuff anymore. E to the 0.03 times 30. Just put it in your calculator. Point 03, 73,788. Yeah? No? If why'd you scrunch it, your eyebrows in?
Oh, God. 10,700.
10,700?
Put it on. I'll read it.
Make sure you keep that 30 in the exponent there.
I got 73,000.
I got 73,788.09. Yeah. How do I put it in? Hang on one second. Okay. So does everybody see the E button?
Yeah.
Okay.
Oh,
So
I have 5 zeros now for.
okay, I did 30,000. Then I press the E button. It gives me a box, and I just put all of that in that box.
Oh, you get the. All right, I got everything out.
Question, did it get the 0.026 when I did that the 0.026? Cause it is, it depends on how y'all put it into your calculator. Oh. Okay. So nobody else, when y'all do these, let me ask you one more question before you leave. I know. Are y'all changing this to a decimal? Did everybody change this to a decimal first?
No.
And y'all didn't get 0.026?
I didn't.
Okay. All right. Anyway, if you, maybe I changed it to a decimal first and I got 0.026. Just make sure you're showing me the work, because if you used 0.026, I did it both ways. My population here was 65,000, and that tiniest decimal place makes a big difference in your answer. So I need to know what you're putting in the calculator, okay? So just make sure you're writing all that out. All right, we will finish some word problems, and then we'll be done with this section next class.